Good morning, my dear serious students. Here is your Durga Shankar sir, your favorite Durga Shankar sir. Today's topic is electric motor. NCERT Standard 10, Chapter 13, page number 232. You all get ready with your textbook 232 and page number 233. Electric motor is a device. See, in your textbook it is written, it is an electrical device. Electric motor is a rotating device that converts electric energy to mechanical energy. This is the very first definition of electric motor. Now, what are the consisting of electric motor? The electric motor consists of a magnetic field. Magnetic field, you know, always it starts from North Pole to South Pole. So here is a magnetic field, North Pole left side and South Pole right side, whatever may be, it may be either side. And this may be a horseshoe magnet. Then only it is possible, one side North Pole and another side South Pole. And in between the North Pole, there is a coil. Coil is made up of copper, and it is the oxidized, insulated copper wire. And this is a coil. This coil is called armature. In your textbook, it is written, this coil is called armature. See, here in this portion, armature. Okay, this line, the coil is called armature. Clear? Now this coil is there, and the coil I have given the name A, B, C, D, just to discuss the position of the different part of the coil. So I have given the name A, B, C, D. It is not actually given. Now this coil end with some split ring, like this, split ring, to give the electrical connection. That split ring is called actually commutator. This split ring is actually called commutator. See, here it is written, the split ring act as commutator. Commutator means automatically change the positive and negative end of the source. This is called commutator. Now, the split ring is connected with some fixed brass X and Y with the source battery E. Here X, Y with the source battery E to give the continuous electrical supply. Okay. Now this is how the electric motor constituted, how it is made. Now this split ring is fixed inner side of the split ring. See, suppose the split ring. This is inner side, this is outer side. Inner side is attached to one axle. It can rotate freely. And outer side is touched with, very tightly touched with the brass X and Y. So it can get the continuous electrical supply. Right? Now, we have to explain how motor works with the help of two figures. In textbook there is only one figure, that that figure may not be enough for your understanding. So I have drawn two figures, so it will be very easily convinced how the motor works. Now let us start the drawing the direction of the electric current. From here you can see, from E, current is going, from E current is going to X. From X it is going to A. From A going to B. From B going to C. From C going to D. From D is going to Q, from D. Now from X it is actually, we correct it, from X it is going to P. From X is going to P. Now from P it is going to A. From A going to B. From B going to C. From C going to D. And from D going to Q. From Q going to Y, and from Y again coming back to E. This is the figure 1. Now when current is coming, suppose you consider from C to D, in your book it is mentioned the direction of current going. Here in current AB, coil ABCD enter from the source battery. This portion you may not follow. So that's why I have explained this portion with the help of arrow like this, and it will be very clear to you, I am sure. Now, according to Fleming's left-hand rule, this middle finger is the current direction. Index finger is the magnetic field, and this thumb is the showing the motion. So current ampere A, magnetic field F, and the motion of the coil armature is called M, motion. So AFM, by this you can remember AFM, simple abbreviation AFM. Now here the current is going down, north to south electrical field, magnetic field, north to south magnetic field, and this is the electrical direction. So the thumb is showing anti-clockwise, thumb is showing the anti-clockwise motion. So CD will come up the board and AB will go down the board and give a rotation. See here in this slate I am showing here. Suppose this is the first position. This is the first position, first figure position. A, B, C, D. Here split ring P, split ring Q. Split ring P is touching X, split ring Q is touching Y brush. When it will have a rotation, see this CD coming this side, AB coming this side. See, now AB, the second figure, the motor took the position of second figure. Now this is the requirement of drawing the second figure. In second figure, AB has gone to the right side and CD come to the left side. Means CD has come to the north pole side and AB gone to the south pole side. Okay? Now, in this case, P is touching Y brush and Q is touching X brush. Now here if we draw the electrical direction, then current direction, then from source E, it is going to first going to X, then it is going to Q. See, instead of going to P, it is going to Q. Now from Q, it is going to D. From D is going to C. From C, it is going to B. From B, it is going to A. From A, it is going to P. From P, it is going to Y, and from Y coming back to E. Okay? Now here, this is the first figure position. This is the first figure position, and this is the second figure position. In the second figure position, again if you apply Fleming's left-hand rule, here magnetic field north to south, current direction B to A, Okay, north to south. This index finger is for magnetic field, north to south. Current direction B to A. So AB is going to turn above the board and CD going to turn below the board. And AB will come to the figure first. So from figure 1 to figure 2 and from figure to figure 1, it is keep rotating, and this is how motor keep rotate, and for the rotation axle is made free, so it will keep rotating by following Fleming's left hand rule. I hope with the help of these two figures, this motor action is very clear to you and you can very easily explain in exam. All the best. Thank you for seeing the video.